Hello everyone, welcome back to lecture 12. This is the second part of this lecture where we will try to understand the application potential of remote sensing in natural hazard studies. So, first let us see the different advantages of geospatial technology in particular. So, we have large aerial coverage when we talk about the satellite images, and especially the remote sensing data sets are non-destructive data collection method. The remote sensing can provide high spatial, spectral and temporal images. It can also provide access to inaccessible areas, real time or near real time data sets that are needed for the hazard studies that can be obtained from remote sensing. Wide range of data across the wavelengths that is also available, because some of the areas which are located at higher altitude, they have the cloud coverage. In such situation, the optical remote sensing data sets cannot be used because of the cloud availability. But in such condition, we have the microwave remote sensing data set that can be used and further analyzed for our parameter. Systematic and repetitive data collection. So, since 1972, I have just explained in the previous part that since then we have the Landsat data, right. So, all of them are having the similar nature. So, as we have seen, the Landsat is having the continuous measurement since 1972, which can be analyzed together to see a particular area, how the things are changing in a given location, right. So, that is the advantage associated with the remote sensing data, particularly when we talk about the hazard studies. So, the hazard prone areas are very difficult to access, particularly during or after disaster. So, that makes the hazard prone areas inaccessible, right. So, because of that we have this physical barriers, rough terrain, dense vegetation, collapsed infrastructure or the hazard itself can make the physical barrier, right. The safety concern, it might be too dangerous for rescue teams, aid workers or even residents to enter or remain in these areas due to ongoing threats. Then the infrastructure damage, remote areas might not have existing roads or transportation networks, making them naturally inaccessible, right. So, these factors indicate the importance of the remote sensing. Because of the remote sensing, we have the access to a inaccessible area. So, the implications of the inaccessibility will lead to challenges for natural disaster response, increased vulnerability of population, difficulty in monitoring and preparedness and prolonged recovery. So, at least with the remote sensing data set, we can have the monitoring and preparedness beforehand, right. So, the remote sensing provides access to an inaccessible area. It helps to overcome the difficulty in monitoring and preparedness, and with the help of all these satellite images, we have different parameters for inaccessible area that can be used to model a particular natural phenomena. So, the data collection through conventional technique or through any other instrument requires disturbing the natural form of the sample. However, with remote sensing based measurement, we have the advantage that we are not even touching the sample or disturbing the natural setting of that particular location. Here this is one case where we are collecting the sample. So, we are naturally disturbing the sample. With the high temporal resolution, we can easily go for monitoring how a particular river is changing its form or geometry over the time, even how a glacier is moving with time, what is the velocity that can be estimated. Consecutive measurement observation at a specific time interval helps to study a phenomena. So, that will give you information about the behavior or the process of a particular problem. So, the high spatial resolution that has further advantage to this So here you can see, if we see the entire earth surface from outside, it will look like this. But slowly, if you have a sensor which is capable in capturing the very specific area with high spatial resolution, that will help you to gather the information about the target in detail, right. So this can have the further advantage in your study. So the role of spatial resolution is very critical in any application, right. So the high spectral resolution, so here it is required to characterize a particular material. We have seen the example in case of hyperspectral remote sensing, that helps you to gather more number of data points across the wavelength, and that will help you to identify a particular material like this one, and this can be considered as a fingerprint of that material. So always we have advantage when we have the high spectral resolution, right. So the wide range of data across the wavelength is available. So here let us see this particular image. Here you have very high cloud coverage. So if I have intention to see the changes in this particular area, but it is blocked by the cloud, right. So we can't have the information, right. So in such cases, remote sensing provides you another option where you can have the microwave data set to identify or to study a particular area, especially when it is under the cloud coverage. So the optical remote sensing data is often difficult to use during a disaster due to frequent cloud cover, particularly in high altitude region. In such a situation, microwave remote sensing becomes a very important source of information. It has cloud penetration capabilities as well as being less vulnerable to atmospheric scattering than shorter wavelength regions, right. So in higher altitude, it is recommended to use the microwave remote sensing when weather is not good. So the near time or near a real time data set during an hazard, you can't access that particular area, but your sensors are continuously working, especially in the higher altitude where you are expecting a lake which may breach. So you can have the continuous monitoring, and then you can monitor the process, how it has happened and when it has happened, right. So this is one example how we are monitoring a particular area with the help of remote sensing data sets. Especially here we have the example of glacial lake formation and then its expansion, right. This is another example from South Lonak. So here you can see how the area is changing over the time, and it has also breached in the recent year, right. Here we have identified or we have monitored the glacial lake over the time. You can see starting from 2008, 2014, then 19, how it is changing with time, right. So how the lake area is changing, that can further be analyzed and to see at what rate it is increasing, then what is the impact of climate on the surrounding glaciers, at what rate it is melting, how much time it will take to fill this particular depression, and then when can we expect this particular lake to breach if the scenario remains same in future. So here you have the example of change in the glacial lake area over the time. So we have started since 1989 to 2022, and we have seen some of the lakes have changed their shape and size over the time, and it is because of the change in the weather condition, particularly in this particular region, right. Based on that, we have used all the parameters derived from remote sensing and the field investigation. Based on the AHP analysis, we have found some of the lakes are falling under the category of high vulnerable lakes. Some of them are in moderately vulnerable, some of them are safe. So here you can see one example from this location. We have also visited and we found this is coming in the moderately vulnerable. So we have to be very careful because this particular lake was showing increase in the size in the last few years. So it has been observed that 8 glacial lakes are highly vulnerable to future GLOF event. This is based on the AHP analysis. So this vulnerability assessment can be done using the remote sensing and the field investigation data set, and you can have a very important conclusion that can save the lives and property in that particular region. This is the example of Sisper Lake breach that happened on 7th May 2022. Here also we have utilized the remote sensing data products as well as the field information to further monitor the lakes, right. This example is from Machoi Glacier, Kashmir, how it is changing its shape and size over the time, that is also given here. This is from Gangotri Glacier with the moraines representing the retreat of the glacier from 1780 to 2001. And it is very important. We all know that Gangotri Glacier is the source of Ganga, right. So here we need to have a very close monitoring of this particular glacier retreat. This example is for the snow glacier dynamics of the Sikkim Himalayas, where again we have used the remote sensing data products, and then those were validated, the classification results were validated using the field information, right. So here we have used different indices to identify the snow cover in this particular region over the time, how it is changing. In another application like physical parameters of snow glaciers, so here we have also visited the field using the field radiometer, where we are measuring the snow dielectric property, and then same has been estimated using the microwave data sets, and together we are deriving different physical properties of the snow glaciers. So here you can see the snow thickness, right. Snow depth estimation can also be done using the remote sensing data set, provided you have very good source of validation, right. So this is another example. Here we have the example of glacier mobility. We can estimate the velocity of the glaciers using the remote sensing data and the data products, and that can be further analyzed or to identify a vulnerable glacier, right. This is another example where we have mapped the avalanches using the remote sensing data sets which were captured from the space, and that has been used to identify and classify the avalanches into two different categories. Here you have the recent avalanches and the old avalanches, right. Then we have also studied the Jemu Glacier for its surface mobility and the thickness and the debris coverage and the temperature profile. These kind of information can be derived using remote sensing data set, right. Then very recently we were successful in studying the seismic deformation of Himalayan glacier using synthetic aperture radar interferometry. So here you can see the coherence image has been used, right, and the vertical displacement has been estimated after earthquake, right. So this is from the Josimath, right, Josimath earthquake which occurred in 2021. Then coming to the flood susceptibility mapping. So we all know that different parameters which are required for flood mapping, they are coming from the remote sensing and the field investigation. So this is one example where susceptibility has been mapped into different classes: very low, low, medium, high and very high, right. So these are the different example. Like in landslide, we can use different methods to map the area susceptibility for the landslide, and here you can see it is also classified into different classes derived from different methods, right. Then particularly for the liquefaction potential, we have also used different methods, different ways to identify a particular location whether it is susceptible to the liquefaction or not. So that can be studied. So here you can see this is one example. So, here the spatiotemporal distribution of parameters for the year 2016 to 17. So, here you can see the PI, standard precipitation index, and the normalized vegetation supply water index has been used to map the drought potential of this particular area. With this, I would like to conclude, and I would like to emphasize on the application potential of remote sensing in hazard studies. So, with the advancement in remote sensing technology and analysis technique, remote sensing has proved to be an important source of information in natural disaster and their impact. So, we will have the detailed discussion of each of the natural hazards which are listed in the syllabus, and we will have the detailed information about each of them. So, with this I will thank all of you.